Okay, this is
Okay.
David Zierler, Director of the Caltech Heritage Project. It's Wednesday, October 13th, 2021. Once again, I'm delighted to be back with Professor John E. Bercaw. John, good to see you again. Thanks for joining me.
Thank you, David. This is fun so far, like you promised.
All right. John, in our first conversation, we took sort of a broad view of your approach to chemistry and teaching and science. Today, I want to go all the way back to the beginning for your personal history. Let's start with your parents. Tell me about them.
Okay. Um, my parents grew up in a little town called Mason, Ohio, which is, I guess it's best known for an amusement park that's near there, Kings Island. But it wasn't there then. And this town was very small, and they met in high school, I think, and got married. I'm the third of four children they had. And I was born in Cincinnati, Ohio, which is where my father lived when they moved out of the town so he could work. But he worked in a as a bread delivery person. He worked for a company called Sunbeam Bread. Maybe you've never heard of it,
No, I have. I have.
but maybe you have. Okay. Anyway, there's many places for that, and he was started out as a. I think he may have worked inside making bread, but he quickly got into sales and into delivery to grocery stores and such. My mother was an only child. My grandfather is one of my heroes. He owned a bank in this little town called Mason, and um, my mother grew up, and neither my mother nor my father went to college. My mother went to a couple of years of what was called a music conservatory in Cincinnati, and she was very good at playing the piano. She played that her whole life, and she taught it part-time also, but mostly she was a housewife. So I was, like I said, born in Cincinnati, but I only spent 4 years there, and then we moved to Tuscaloosa, Alabama, because my father had a much better opportunity to be in management in a factory there. So you want to know more about my parents, or
Yeah,
what's
what
up?
what were their experiences during the Great Depression and World War II?
Um, well, they didn't talk that much about it, I guess. My father did not serve in the military. I think he was in the National Guard, but he had uh, something about broken arches or something like that he didn't pass the health exam, so he wasn't able to go. But they spent the time surviving in the U.S. during World War II, and I don't really know of anything terrible that happened to them. But like everybody, they dealt with shortages at home uh, and got through it. And he was when we were younger, he wasn't particularly well paid. We were sort of a lower middle class, maybe middle class family, but he became very successful, and we had a very comfortable upper middle class sort of existence later on. So he suffered through the Great Depression and World War II, but he came out of it fine, of course.
John, if not your parents, was there anybody else in your family, in your extended family, who exhibited strength in the sciences?
Yes, the oldest child is my only brother. I have two sisters also. One is younger, and one is older than I. But the oldest child was my brother. Uh, he was also called Jim. My father's name was James, and he was also James, and they both went by Jim. But Jim was an electrical engineer, and when we moved to Tuscaloosa, Alabama, he went to school at the University of Alabama there in engineering, and he was very successful. He went first to Bell Labs, and then he worked in Western Electric, and eventually became much more in management than in sciences. But when he was influencing me was when we shared a bedroom in Tuscaloosa, and he would be up at all hours working problem sets and such and reading. Um, to get through his coursework. But I think I'd already decided I wanted to be a scientist, not so much by watching him, but just because I loved it. And he encouraged me greatly because he saw something in me that I guess I had, and that was an ability to grasp scientific concepts pretty easily. See, I remember him lecturing me on how semiconductors worked, and I asked good questions. And so he actually gave me, I guess, 1963. I guess I was 19 years old. Maybe I was in high school at that point. But he gave me what's called the Handbook of Chemistry and Physics. I don't know if you've ever seen one of these. It has about 3,000 pages, but it's printed on what's called India paper, which is very thin. So it's not, massive, but it has data for all kinds of things like the melting points of compounds and, lots of, engineering terms about, coefficients of expansion and things like that. And I used that repeatedly. I still have it. They still publish it, but they abbreviated it over time. And so I had kept that thing that he gave me ever since he gave it to me. I'm still using it to great benefit. And that was just sort of evidence of how he wanted me to think about being a scientist or an engineer. I thought I wanted to be an engineer when I went to college, but I quickly learned that no, I needed to know the fundamentals of science, not just fit models to observed, phenomena.
John, after those early years,
he was probably
after those early years in Ohio, did you spend the rest of your childhood in Tuscaloosa?
No, I only spent 8 years there, I think. Even then, I was going to the library and checking out chemistry books. So before I was 12, I knew I wanted to be a chemist. I had some romantic idea that I would have a laboratory in a very cold, snowy place because I like snow for some reason. And I dreamt about being in northern Minnesota in my own laboratory doing science. So I read chemistry textbooks and biographies of scientists and went to the library and checked all these books out and read them. And my mother never ceased to be amazed at the craziness I was doing. When I was in Alabama, I think it was about the time when Sputnik went off, and I became interested in becoming a rocketeer. So we did really foolish things in retrospect, like making rocket fuel. And I also had a book on pyrotechnics. I made my own pyrotechnics. I ordered chemicals from some supply house that would send me dynamite fuse and all of these components in fireworks, like sodium perchlorate and aluminum dust, antimony sulfide, and all of these compounds that if you make pyrotechnics, you'll recognize that that's what I was going to do with this order. But they sent it to me anyway. I had to have my father's signature because they had to ship it by Railway Express. They couldn't put it in a truck. And so I remember asking him, would you please sign this order for me? I guess I had enough money to buy it. I worked part-time during most of my life, working in my father's bakery, doing various jobs. But anyway, I wanted to order this stuff, and he looked at the list and he couldn't make heads or tails of it because he wasn't a scientist. But I said, yeah, I want to fool around with some chemicals here. Would you mind signing this? They have to send it by Railway Express. And he said, oh, all right. So he agreed to do it. But yeah, I was in Alabama in my sort of beginnings of my love of science. And it's amazing because the schooling I received in Alabama was just dreadful. I was in elementary school there. I began first grade, I guess, and went through, I think, about fifth grade there. And it was not good. They did their best to discourage me from trying to learn things. I mean, not purposely, but their whole system was crazy. For example, when I was in third grade, I guess the principal and some of the teachers got together and decided there were 4 or 5 of us who were especially talented. And so we were being held back. And so they sent us all the way to the 5th grade after we graduated from 3rd grade. And so we missed 4th grade completely. And we didn't miss very much because we were able to do 5th grade just fine. But then after the 5th grade, they quit sort of treating us a little bit differently. And they said, well, we can't continue with this program because we don't have the manpower to do it. So you'll have to stay in 5th grade for another year, all of you. And so it was amazing that we went through the 5th grade twice and not 4th grade, but we survived. And then I moved to Greensboro, North Carolina with my father, who got an even better job there. I remember thinking, boy, I'm really going to have to work my butt off to catch up, because it turns out Greensboro, especially at that time, I think it's still true, had a very good school system. And so the classes were challenging, and I really had to apply myself, whereas in Alabama, it was a real loss. And I was mainly playing sports and things like that with my friends instead of working homework problems and still getting through with A's and stuff. But anyway, Greensboro's school system was a good thing for me because it sort of slapped me back into reality.
John, it's notable. It's notable that as a young kid, it wasn't just the chemistry you were interested in. You wanted to learn about the biographies, the chemists who made the science possible. Were there any specific chemists that were heroes to you as a kid, or people that you looked up to, or you really admired their approach to chemistry?
I guess it was more scientists than chemists. You know, Einstein and you know, the modern physics were being accepted and so forth, and I was interested in that kind of thing. But I also read about explorers, and it was more than just scientists, but I did read scientific books. And I can't even remember a chemist that I read about. I don't know what it was about chemistry that was so fascinating to me, but I just liked the subject, and I was of course learning a lot about it without ever having a class in it. I remember when I was in junior high, I ordered a glass retort. I don't know if you know what a glass retort is, but it's one of these tubes that tapers, and on the other end of where it comes out is this bulb. So it's sort of like a flask with an attached tube. So it's sort of an alchemic piece of apparatus that you might have seen in various cartoons or movies or something. And it had a glass stopper on it. And I got this glass retort, and I decided I wanted to use it for something, you know, really cool. So I made elemental bromine from potassium bromide, concentrated sulfuric acid. And you had to heat those two together to get the sulfuric acid to oxidize the bromide into the elemental Br2. And that stuff is really potent. It's very heavy, because you might guess from its atomic weight. But so you collect it in a test tube, and you put an ice bath around it to try to keep the vapor pressure down. And I had this experiment going on in my bedroom in the upper floor of the the double layer house that we had, and all my family were downstairs, and the bromine vapors came out of the test tube, and since it was so heavy, it just ran along the floor till it got to the stairs, and it ran down into the living room. And my father came upstairs, and he said, "What in the hell are you doing? You're killing us all upstairs." I still remember that. And he just shook his head. So this was typical of what I was doing as a child, reading about how to make bromine, and then ordering the glassware for it. And then somehow I got a hold of concentrated sulfuric acid, which is not easy to obtain. But back then you could buy things like that and have them shipped to you, or even in the pharmacy you could find some really cool chemicals. So anyway, I was playing with that. And I guess I'll finish with my mother. I decided I wanted to to follow the recipe for making rocket fuel, which was you could I made mostly zinc dust mixed with sulfur, which is a relatively easy thing to do. Just mix the zinc dust, which is galvanizing. They take the dust and melt it and dip a piece of steel into it and put a zinc coating on it. So the zinc dust was plentiful, and flowers of sulfur you can buy anywhere. So you just mix those two together, and if you pack it into a rocket motor, it burns and makes zinc sulfide, which is solid. So it's a very smoky proposition, but the thing goes off, and you're able to get a rocket motor to actually lift the rocket off the ground. But I wanted to try this other formula, which was made with what's called saltpeter or potassium nitrate and sucrose, which is common sugar. And you have to melt them, I think at like 300 degrees Fahrenheit, maybe 350, I don't remember exactly, but you can't take it higher than about 450 or it'll ignite and go off in a hurry at that temperature. And so I was thinking, how am I going to make sure it's at 350 and no more degrees? And I thought, well, put it in the oven. So I mixed the components on a cookie sheet and put it in the oven. And I was sort of watching, opening the door occasionally. And my mother came in the kitchen and she said, "What are you doing there, John?" I said, "I'm making rocket fuel, Mom. I'm melting sugar and potassium nitrate together." Then you take the liquid, because it made it into a liquid, and you pour it into the rocket motor. But this was before that. Anyway, she looked very alarmed as she ran to the phone and called my father. And she said, Johnny's making rocket fuel in the oven. What do I do?" My father said, I think it's apocryphal partly, but he claims that he said, "Get the hell out of the house." She got out of the house until I was finished filling the motor with that. It was just an aluminum tube, and it was a foolish thing to pour into it, because when I did ignite it, it just melted the aluminum tube and flowed out all over the place. So it was a failed experiment, but it was okay because it didn't detonate in the oven.
Oh, that's good. That's good.
Anyway, my mom and my dad were very patient with this kid who was fooling around with things they didn't understand at all. And they didn't discourage me. Except one time I did get a carbon dioxide, those cartridges that power air rifles, and also you carbonate water, for drinking with them. Anyway, I used to take those and fill them with zinc dust and sulfur and ignite the end and shoot them out of an aluminum tube, and they would go like a mortar. And I had my little sister out in the driveway with me, and one of them took off, and they didn't have any fins or any kind of stabilization of their flight path. So they were just sort of, especially if they weren't packed right, they wouldn't go very far. They would just spin around, and it went zooming into the garage right by the two of us. My little sister was standing next to me watching me do this craziness, and it hit the wall of the garage and detonated. An enormous explosion went off. And my father came out from the house and saw us standing there, and the garage was full of smoke. And I told him what happened, and he's okay. No more chemistry for you, John. That's it. You're going to kill yourself, and I'm not going to be part of that. So he took my chemicals away from me for about a year or so. I eventually talked him into letting me try again. So apart from that temporary period where I wasn't allowed to fool around, I did play with chemistry most of my high school, all the way up through high school.
John, in Tuscaloosa, you were a small kid. You were a small kid, of course, but I'm curious if you have a specific memory if Tuscaloosa was more integrated or segregated when you were there.
It was totally segregated. I grew up in that. It was normal to go to the movie theater and see drinking fountains for colored and also white people, separate. Bathrooms are separate, and everybody just sort of, that was the way life was. And that was true also in Greensboro when I first went there. Although that was the period where the beginnings of the civil rights movements and so forth were taking place. And by the time I went to college in NC State. When I was there, my freshman year, I remember my best friend in high school, who was also in the accelerated classes with me, he was my roommate in NC State, and he was very much more passionate about civil rights issues and so forth. And I would go with him sometimes to register Black people in Raleigh and the nearby towns and so forth to vote, register them to vote. And they were very receptive to people like me walking up and knocking on their door and asking them to register and please vote. But that was when it was starting to change. But also, it influenced my choice of where to go to graduate school. Almost all of my NC State colleagues that got a bachelor's degree in chemistry either took a job in industry or went to graduate school, which is a much more sensible thing to do with BS in chemistry, is to get more education. Anyway, if they did go to graduate school, they went to some school in the Southeast. And so that's why I decided to go to Michigan. I applied at schools, and I remember I applied to Rutgers and a couple of other schools. And at that point, I started to learn about Caltech. And I thought, wow, that's a cool place. There's no way I'd ever get into Caltech. I thought so. That would be hopeless. So I didn't bother to apply. But I got into Michigan, which was, especially at that time, one of the best graduate schools in chemistry. And so my wife and I, we got married after my sophomore year at NC State. We took off for Ann Arbor, Michigan, and I thought it would be, I was very naive. I thought, well, there's a bunch of bigots and racists in the Southeast, so I'm getting out of here. But I found out soon after I got to Ann Arbor that it's everywhere.
Yeah.
Especially with Ypsilanti being very close to Ann Arbor, and that's full of auto workers. And they were vocal about their racism and so forth. So,
John, in high school, did you want to stay close to home? Was that the primary motivation for going to NC State?
You mean after high school? Yeah.
Yeah.
Yeah. I guess I did. I thought I wanted to be a chemical engineer, and I knew that University of North Carolina had a much better reputation in chemistry, but I thought I wanted to be a chemical engineer. And the state school is usually the engineering and agricultural school, and that was true in North Carolina as well. So I went to NC State. I don't think Carolina they may have a small engineering school now, but I don't think Chapel Hill ever would have been a good place for me for engineering. But I started out in chemical engineering, but it didn't matter. I had the same curriculum pretty much as chemistry anyway for the first couple of years. But yeah, I guess I still wanted to stay close to home. I went back on the weekends with my wife, and after we got married, and even before that, I would go back occasionally on the weekends just to see my family and spend a little time at home. But I guess I had more familiarity with North Carolina schools, and so I didn't really apply to very many after high school except in North Carolina. I think I might have applied to Georgia Tech because I was considering that.
John, as an undergraduate, did you have any labs or summer work that was really formative in your intellectual development?
Well, labs are very much a part of the chemistry curriculum. At least they used to be. Pretty much every subject had a lab. Well, freshman lab was very many hours a week. I went to those. I thought they were okay. They were mostly analytical chemistry and a little bit of physical chemistry. But early on, I really liked the subject of inorganic chemistry. And I didn't particularly like organic as an undergraduate. But I had a tumultuous sophomore year because um, my roommate, I told you my roommate was my best friend in high school, and his father and my future wife's father were roommates at North Carolina State. And so he was ultimately a colonel in the Air Force. And um, so he was moving from Tucson, Arizona to England for a new assignment. And he sent his daughter, Diane, the oldest daughter, he had 4 daughters, and Diane was the oldest, sent her back to NC State, where he was an undergraduate. And that was a very unusual decision because at that time, NC State was mostly men, and it had just gone co-ed a few years earlier. So there were only a couple of hundred women on campus. But I got to know her through this guy, Lawrence, who was my best friend and roommate. And so we started dating. And so it was hard for me to keep working really hard in the classroom and still, go dating and going out to dinner and to movies and things like that with somebody I really cared about, especially because she was relatively attractive, and the football team and the baseball team were always hustling her and trying to get a date with her. And they were puzzled by her going, out for a beer with me, walking into a bar full of men, and there was this good-looking woman with a nerd. And they wondered what she saw in me. But anyway, so I had a lot of distraction, I'll say that, in my sophomore year. So finally, after I didn't do well in organic chemistry, I took her aside and I said, Diane, we're either going to have to break up or we're going to have to get married, because I can't go on like this anymore and be successful at school. And school's very important to me too. And she said, "Oh, I'd love to get married." So she wanted to drop out of school anyway because she was in education and she didn't like the curriculum at all. She ultimately got her degree in accounting, but she dropped out and became a bank teller. And I guess back to your question about lab. Eventually, I was very good in lab, and I decided to go ask the lady who was in charge of, her name was Mrs. Manning, in charge of all the labs, the sophomore organic labs and the freshman labs. And I would be the assistant that would prepare all the solutions, and I would be the one who would titrate the acids strengths by, you titrate it with a base and you figure out the molarity. And everybody got an A if they got my number, that kind of thing. So she had a lot of faith in me and became very fond of me and encouraged me. And so I was also making up samples for organic lab, and even though I hadn't had organic at that point. But we worked hard because when we decided to get married, my parents were not happy with that decision. They thought that I was going to ruin my career by getting married so early, and that I should stick to studying hard and not be distracted by having a life. And her father was not very happy that she was getting married either. And so they more or less, they completely did cut us off. Okay, if you're going to get married, you're going to support yourself through college. And so that's why she started working in the bank. And when I started working in the lab, I was making a pittance compared to her, but we were able to survive. And those were pretty desperate times when you have to live on whatever you're making in those kinds of jobs. And so we managed and we got through. And eventually my parents realized that wasn't a great decision they made on my behalf. And they bent over backwards to sort of help me after I graduated with honors from NC State, and did well enough to get accepted to graduate school in a place like Michigan. And so they were generous. he gave me a couple of cars and that kind of thing. So I think there was some guilt there. But in any case, I was working in the lab and I was doing the other labs, structured labs too. And I found that doing chemistry was really fun. And mixing solutions and looking at precipitation and color changes and things like that was really something I really enjoyed.
John, as a married man,
So
was the draft something that you did not have to contend with?
yeah, that was a big issue, but somehow I squeaked in. When they started the draft, I didn't have to get a number because I was married. I didn't have any kids, but I was married, and so that wasn't an issue. And then when I went to Michigan, Diane was happy to go to graduate school. I mean, she's being very patient, right? She got me through, more or less got me through undergraduate school. Now I want to go to graduate school. And, that fueled her father's impression that I was a, career student. I was never going to amount to anything. But she agreed but she wanted to start a family. So in my first year at Michigan, we had my son. And I guess about a year later, they said, well, it doesn't matter if you're married or not, you're still going to be part of the draft unless you have a kid. And so I was considered, I think it was 3A or some such classification where it would be a hardship for you to go in the military for two people or more people if they're part of your family. So I was never part of the draft, but I watched it around me, and it was really terrible what it did to people. Here we are in Ann Arbor, Michigan, not far from Detroit and not far from Canada, and many people, made the torturous decision to just leave and go to Canada so they wouldn't have to go to Vietnam. But back to NC State, when I was in my first 2 years, NC State had very strict requirements that you be part of what's called Reserve Officers Training School. And that meant you had to either choose the Army or the Air Force. And I guess the Navy wasn't considered possible. But anyway, I chose the Army, and I had to go clean an M1 rifle once a week. And I had to go for dress parade on the football field once every week too, and march around as part of the squad. And Diane she was also an undergraduate at NC State then. She was in the Air Force ROTC, and she had to do that also. A couple of years after that, they decided that wasn't a good requirement to have for NC State. We're not a military school, and so they did away with that requirement. But the whole second year that I was in ROTC, they had classrooms also. They taught you how to fight and what the sort of catchphrases were for people who were in the military. And they were trying to talk us into signing up for advanced ROTC, where and when you graduated, you would become a second lieutenant and go to Vietnam. And I was smart enough to know that was not a good idea, because I wasn't in love with the military then. I was much more sympathetic to those people who were objecting to the war and so forth. So I got through it, and I resisted going on to ROTC, advanced ROTC, and that was a good decision. And Diane was happy with that too. But anyway, I watched the war, heating up, and Lyndon Johnson took over from Kennedy. I was a freshman. I remember I was shining my shoes from going out dress parading when I was listening to the radio and I heard about John Kennedy's assassination. I was in my dorm room doing that. So I went through that, and Lyndon Johnson, and when he ran for president after that, he actually visited Raleigh. I shook his hand and went to see him. And I heard about the war through that. And then when I went to Michigan, it was very much more conscientious objection going on there. And not only about the war, but also uh, um, the equal rights for Black people and so forth. And there were all kinds of demonstrations going on campus. So I remember I was working in the lab and people would march through the halls of the labs and be wielding pipes and trying to get people to get out of the lab and join the strike. We had all kinds of meetings with faculty and administration trying to calm us down. And even though I didn't want to participate in those things at that point, because I could see that I might want to do something that would require some kind of security clearance for me ultimately, and I didn't want to have an arrest on my record at that point. And I figured that I should just keep my head down about this. And when I talked to my friends, I would be supportive, but they understood that I didn't want to do that. I remember they used to talk to me and they'd say, "John, you're never going to be a real objector. You're just a chemist at heart, and you're going to be a chemist your whole life. So you should keep doing that." So they were understanding. But there was a lot of that stuff going on, and I somehow didn't get it. I didn't get drafted, but people were really nervous about that. That were my classmates.
John, by the time you got to Ann Arbor, how well focused were you in terms of the kind of chemistry you wanted to pursue for your thesis research?
I became pretty focused at NC State. I liked chemistry a lot, and I took the chemistry curriculum. By the way, I did a senior research thesis with a physical chemist on something called Mossbauer spectroscopy, which is used to help analyze certain elements that have metastable excited states that were close to the ground state, so that they could do a resonance absorption and so forth. It was just coming on board, this new spectroscopy invented by Mossbauer, who got the Nobel Prize for that invention. But anyway, I was doing that as a senior thesis, and because I was working with this cobalt source of ultraviolet radiation that irradiated the iron centers in minerals, I was fooling around with radioactive things, and I thought, wow, this is cool. So I took more and more courses. I think I took 3 or 4 courses in nuclear physics, even as an undergraduate, because I was fascinated by nuclear weapons and radioactivity, and I like that kind of physics. I didn't like plasma physics and electromagnet. I took electricity and magnetism as a freshman at University of Michigan. I almost got killed because I was thrown in there with a bunch of physics majors that were, killing all of the advanced calculus that I didn't have at all in my background. But I struggled through and got a C or a B. I don't remember. But anyway, I did like the nuclear physics courses and the structure of the nucleus and all of that, which is interesting because you may know in my later years, I actually went to the weapons labs and served as a consultant for them on panels. And I got tours there of classified things I never would have seen if I hadn't been accepted as a panel member. But that sort of went back to my affection for explosions and rockets and things. I thought, wow, that's the ultimate bomb right there. Let's know how that works. And I eventually got around to reading the Rhodes books on the making of the hydrogen bomb, the making of the atomic bomb, and then the follow-up on the thermonuclear hydrogen bomb. But anyway, I took these courses I took these courses as an undergraduate and also did a senior thesis on that. So when I decided to go to Michigan, I chose Michigan over a couple of other schools I was accepted to because they had a reactor on campus. And I thought I would be doing things like neutron activation of elements, which is where you put a sample into a reactor and the neutrons are absorbed by the nucleus, and then you take it out and use it separate it if you need to, and so forth. A lot of stuff that went into making the hydrogen bomb. And I guess I didn't tell you that I worked one summer with plutonium at a DuPont laboratory in Savannah River, where they make the plutonium and also make the tritium and all these other radioactive isotopes in a site called Savannah River Plant. And I was accepted as a student before I went to Michigan. We spent 3 months in Augusta, Georgia, and I drove over to the lab every day. Had to have a top secret clearance for that. So it's good that I kept my nose clean when I was going around doing these, registering of Black people and marching to some extent. But anyway, I worked with plutonium for 3 months. Actually, I had to go in the lab, and this is plutonium-239. That was a sample they had on hand, and they didn't work with the less radioactive stuff. This is really deadly stuff. You don't want to ingest it. And so I had to put on these, lab coats and hairnets and tape 2 latex gloves onto my hands and count myself when I went into the lab and out, because a very small amount, well less than a milligram that's ingested will be lethal. And so the health physics people are all over you, especially if you're a recent bachelor's degree graduate. I worked in the analytical lab where they sort of kept track of the plutonium production, purities, and so forth before they sent it out to Colorado or wherever to have the nuclear weapon fabricated. And so that also encouraged me to go to Michigan because I had experience now. I'd accepted at Michigan already, so I guess they were more willing to take me at Savannah River. But I worked there, and I was pretty much sure I wanted to do nuclear chemistry when I got there. Where you really work with with radioactive elements and do chemistry on those elements. But when I got to Michigan and I started talking to professors, I soon figured out that all the stuff they were doing was just fancy analytical chemistry, and there was, there wasn't any real intellectual frontier that I could see there. It was just sort of building methods for detection of this and that, and analyzing in great detail all of these things. And analytical chemistry never really appealed to me all that much, so I used it, but I didn't think it was a frontier area for me. And there was this young guy in my freshman year at Michigan who was from Germany I took a course from him. He was really an exciting guy. He taught inorganic chemistry, and I did the inorganic laboratory, and he was in charge of that. And after about 2 or 3 months of working in the lab, he came up to me privately and said, "How would you like to work in my lab in the summer? I have an opening, and maybe you would like to just try out my lab." And I said, "Sure, that would be great." So that was the beginning of my turning around completely toward what I ultimately did, which was organometallic chemistry. He was doing,
and this is Hans Herbert Brinsinger you're talking about.
That's correct. Yes. I guess you may not know, but he died about 2 or 3 years ago. He was a good friend my whole life. I saw him about a year. He came and spent the summer 3 months with me in Ann Arbor. In Pasadena, working in my labs, doing some experiments he could only do at Caltech, where we had the equipment to do it. And we published a paper right after he died. But anyway, that was the beginning. So I was one of his very first students, and maybe the first PhD that he produced. I'm not sure. It could have been somebody else, but I was one or the second that finished with him. And we spent lots of time together. I was completely in love with what I was doing.
John,
We used to go.
what
We
was
used
it
to.
about Brinsinger's approach or to this new area of chemistry that spoke to you so clearly?
Um, I don't know how to define why you have an affection for somebody so well. I don't know how to define it well. But he was excited, and he was as dedicated as I was. I I would work. I mean, this is now my wife had our son David while I was working with Hans Brinsinger, and she would be at home in university housing with the son, and I would be working. I would go back after dinner. I would work until sometimes I worked all night. I would work 24 to even more hours because the compound I worked with first was not very stable thermally, and so I had to do the experiment after I made it, and that took another 12 hours. So I wouldn't sleep for, God, I don't know, 36 hours sometimes, and then I would take the bus back to the housing where we lived, and I would sleep for 12 hours, and then I would go back and work in the lab. So you can tell my wife was the same. But Hans Brinsinger was equally excited about what we were doing, and we would go one on one. We would go up and use instrumentation on the North Campus that was in some engineering building, and run spectra on our samples. And he would be there at night with me sometimes also. And so his total love for what we were doing was just contagious. So I got it even worse than he did. So I really had a lifelong friend there. And ultimately was just an assistant professor and started professor, and that's part of that was we did together that got him promoted, because it was clear that it was very hard, and we were inventing methods for handling these compounds that you would take a sample and open it to the air, and it would just spontaneously catch fire because it was so air sensitive. So you had to be very careful to exclude air. We were lucky at Michigan because there were groups that worked with things like boron hydrides and phosphine hydrides and so forth that are also, these are main group, not transition metal organometallic compounds, but they had methodologies that we adapted to what we were working on. So we had a lot of glass blowing. I learned how to blow glass myself, and I made some of my own equipment. So everything was new, and the field was brand new. Organometallic chemistry was not a very exciting area until transition metal organometallic chemistry took off, and that was in the late 50s, early 60s, and I was going to grad school, starting out in, I guess it was 67 or 68. So we were right there at the beginning, and everything was exciting and new, and he was working in that area I wanted to be in. So anyway, he was a good friend, and he and his wife would invite Diana and me to their home for dinner because I was an unusual student. I had a wife, so we became good personal friends too. And then after he got promoted to full professor, he got a chance to return to Germany. He was a German, but his wife was Swiss, and the school is Constance, which is on Bodensee, which is part of the Rhine River that runs between Switzerland and Germany. And so he took that job in Germany and left Michigan about 2 or 3 years after I finished with him. And he would invite me to go to Germany and bring Diane along and my family if I wanted. So it was a lifelong friendship, as I said, and we were both very dedicated to each other. But he kept working in this area and sort of alongside in similar projects and so forth to the things I was doing at Caltech. But he told me that the group whenever he would mention my name, the group would sort of chide him and say, "Oh, you mean the great John Bercaw, not John Bercaw."
John,
And I gather
what were some of the principal conclusions of your thesis, and how were they responsive to some of the key questions, given that the field was so young at this point?
yeah. Well, what we were trying to do was follow up on some work done by a Russian chemist who I later met, who was a fantastic guy, Mark Volpin. He had reports of these reagents made with titanium that would fix nitrogen, that is, take nitrogen gas and convert it into a reduced form that you could hybridize to ammonia. And Hans had some interest in bioinorganic chemistry when he was in Germany before he came to Michigan. And so I think that sort of spurred his interest in this. And so we were trying to make these titanium compounds that would react with dinitrogen. So you have to do it under pressure to get it to go fast enough, but we had these high pressure reactors up in a special room in the lab. But we devised a way to make something called titanosine. That's like, I don't know if you've heard of ferrocene. It's a sandwich compound that has an iron atom sandwiched between these two 5-member variants. And we made a hydride of titanium that we couldn't crystallize it. This was the thing that decomposed so quickly. But we would do all kinds of experiments that would prove that it was a titanium hydride using vacuum lines and so forth. And this was an unusual structure. It was like the boron hydride. It formed a dimer in the same way with double hydrogen bridges. That was our first paper. And then we showed that you could treat this hydride with dinitrogen and it would form a dinitrogen species that somehow got reduced. And we tried to figure out how that worked. But along the way, we did all kinds of other chemistry with it. And then I had the idea, and I always like to tell Hans that he just made me mad when he said this. The reason that this compound was so unstable was that it kept reacting with the CH bonds of its own ligands and breaking the carbon-hydrogen bonds to decompose. And so I said, well, let's just get rid of those hydrogens and put methyl groups there. And so we had these models, molecular models that you could make, and I built one of them of this thing I decided I wanted to make. And Hans said, don't even bother, John. It will never work because it's too crowded to fit around the titanium with all those methyl groups banging into each other. It just won't stay together. And I remember I said, watch me. So I figured out how to make it. And it turned out it was much more stable, and not for the reasons that I thought it would be, but everything was crystalline, beautiful, and wonderful. And so I made that at the end of my thesis work with Hans. And so that was the first of these really bulky cyclopentadienyl compounds of these early metals like titanium that I made and reported. And I think that got a lot more attention in the end. And I remember when I decided to go off and work with Jack Halpern as a postdoc, I told him I probably would want to be an academic. And and he said, well, why don't you continue working on the stuff that you insisted on making with pentamethyl cyclopentadienyl groups? And I said, okay. I had a very good colleague who was on my thesis committee who made things with methyl groups. They weren't cyclopentadienyl ligands, but he had made, I heard from rumors around the department that he had made this relatively large quantity, I think like 50 milliliters of this, the precursor to the cyclopentadienide. And he had it, and he had it. And so I went to see him and I said, I'm really excited about making this titanium compound that has these methyl groups all over the cyclopentadienyls. And I understand you have some cyclopentadiene in your refrigerator? And he said, yes, I have 50 milliliters. And he said, okay, I'll make you a deal. I'm so excited. I want to make it right away. So if you give me that 50 milliliters, I'll give you 100 milliliters when I repeat the prep and make it on a bigger scale. And he said, okay. And he was very generous. And I gave him 100 milliliters later. And he said, you didn't really have to do that. But I said, no, that was the deal. And so I was able to get going on that project really quickly because I sniffed around the department and found the right compound. His name is Arthur Ashe, and he still remembers me coming in his office and selling him on giving me $50, 50 milliliters of that compound. But anyway, I think we published some really nice work, and people heard him talk and were very impressed. My colleague now, Bob Grubbs, is a couple of years older than me, and he was just starting out at Michigan State then, and he said he still remembers Hans coming and giving a seminar at Michigan State on the work that we were doing, and he mentioned this boy from the southeastern part of the United States who was working with him and was really very good. He mentioned my name, but Bob told me many years later when he became my colleague at Caltech, he said, "Oh, I remember Hans. We used to call him Hans the Sandwich Man, the sandwich compound man."
Yeah.
And he said he gave a great lecture at Michigan State, and everybody was so impressed by it. So he gave a very good lecture, and he gave a very good course that I learned a lot in when I was at Michigan. So,
John, did you know Jack Halpern? Did you know Jack Halpern before you got to Chicago?
No. I was ready to graduate. I'd only been at Michigan for 3 years, and I started thinking about postdocs. And I actually finished in 3.5 years because I had to get out of there. Diane was ready to move on. She had enough of this stuff. And so I decided, actually before I went to postdoc, I decided I better get a job now, a real job in the chemical industry. So I applied at Procter & Gamble. No, that was when I got my bachelor's degree. No, I applied to several places. I got an interview at General Electric. They have a chemistry lab in Schenectady, New York. And I actually interviewed there. There was only one other interviewer and interviewee. And he was a guy from MIT who had worked for his famous inorganic chemist, Dietmar Seyfarth. And they hired him, and they didn't hire me. So I didn't have a chance to work in industry. There were no jobs in the early 70s for chemists. I've never seen it as bad as it was then. And so I decided maybe I better go on and do a postdoc. And so I asked Hans, of course, Hans Prinzinger, who I should think about going to work for. And he said, you should go to work for somebody who does something totally different than you. Don't go work for somebody who does synthesis. You know more than anybody I've ever seen about synthesis already. Learn something new. So he recommended that I apply to Roald Hoffman, who's still at Cornell. He was at Cornell at the time. And also to Jack Halpern and a couple of other people like Jack Halpern. Roald Hoffman was somebody who applied theory to organometallic chemistry. And Hans was very taken by that. It was just becoming popular to do that. Roald was very good at it. Roald, I think, even though I had no experience at all in doing theory, I think he would have taken me as a postdoc. He told me that later. He said, your application, I still remember. And I said, but I had no experience at all with theory. All I did was experiments. And he said, that's fine. In fact, I prefer people like that because they don't have these biases towards something wrong. And I said, okay. Well, anyway, we became good friends, actually. But Jack Halpern called me on the phone after I had written a letter and sent him an application. It was a very funny conversation because he said, I have a postdoc opening. And I said, well, that's good to hear because I've applied for that position. And he said, if I offer you this position, will you take it? I said, well, I haven't talked to you before this, so it's sort of off the cuff, but yeah, sure, I'll take it. And so I took the job. And the first time I ever met him, I'd already accepted the position and, had driven to the University of Chicago and finally went in and met him in his office. So it wasn't at all like it is now, where you have to pretty much go interview at places that you're interested in. When you go to graduate school, you have to go visit the schools, and most people want to do that so they can make a good choice. And the schools actually pay for you to go, at least in chemistry, and look them over, and they put on a show for you. But I didn't do any of that for even going into Michigan. I just read the brochures, and some of the faculty wrote me letters of encouragement to come. But Hans Brinzinger wasn't one of them. I told them I was interested in nuclear chemistry, so those people wrote me. But Jack I knew of his work. He was one of the pioneers of organometallic chemistry, and he did mechanism. He studied how reactions work, and that means doing a lot of kinetics and labeling studies. He drew up ideas he and Roald Hoffman, actually, and a guy named Jim Coleman had these general principles that they were espousing. And so he was a very famous guy. And I read his papers, Jack Halpern's papers, very carefully. I knew I wanted to do mechanism. But when I got to work for Jack that first day, I said, what kinds of projects are you interested in having me think about? And he told me about a project. He said, we've been trying to make this compound and isolate it in a pure form for 3 years, and we've been unsuccessful. And I understand from your letters that you're very good at synthesis. I want you to go in the lab and make this compound and crystallize it. And I was sort of crestfallen, but I didn't show it, I don't think. So I said, well, I better do what he says to start with. So I figured out I had to actually make something, some equipment so that I could handle this stuff. It was very, very sensitive. And that's why people were having so much trouble with it. So I made that, and meanwhile, Jack's students and postdocs are looking at people. What is it that you're making? Well, I have to have this called a Schlenk line if I'm going to work with this compound because it's very sensitive. And, wow, okay. And so I made a Schlenk line, made the compound. I finally got it to crystallize. The first time was really hard. After that, it crystallized every time for me. And it's air sensitive, so it makes no sense. I still don't understand that today. Some people claim that, there are seed crystals that get in the glassware you're working with, so that the next time we try to crystallize it, those seed crystals make it work. But that couldn't have been true of my compound because it reacts with air so easily. And people like Fisher made crystals of sugars, and he had to have special glassware that he had seed crystals in. So he's a famous example of that. And when he moved labs, he had to move all of his glassware to the new lab to get things to work again. But anyway, I made this compound and got it isolated. And then without Jack telling me, I was going to group meetings, watching people doing experiments, and I decided, okay, I'm going to study some mechanism for this compound. So I started oxidizing it for some reason with very cyanide. And it was a beautifully clean reaction. And so I started following it by the color changes and isolating the products and so forth. And Jack Halpern was a very interesting guy. He was very, very famous, very busy, and he traveled a lot. But when he came back, he would go down to the lab which was sort of linear. And he would go from blackboard to blackboard right next to where the postdocs were sitting, or the students, in this case, the postdocs. And he came to the blackboard, my blackboard, and he said, "Well, John, how are things going?" And I said, "They're going great, Jack." And he said, nothing. He didn't say anything. He just looked at me. And I looked at him. And then he walked on to the next blackboard. And then I realized, wait a minute, I was supposed to say a lot more than "they're going great, Jack." I was supposed to explain why they're going great. So the next time he came, the next month he came, I was ready. And so he was just fascinated. He stayed with me for at least an hour and told me a lot of things about how I was doing things that could be done better if I tried this instead of that. And so he was very very supportive of me doing this sort of independently, and he thought it was reasonably important. And I've always been very talkative and interested in group meetings and ask questions and things like that. And so I would be a vocal participant in the group meetings that we had. And so vocal, I think that the other postdocs, who were mostly from Europe and Asia, took me aside after a group meeting and said, "John, in group meeting, Jack talks. You don't talk. You shut up." And I just shook my head and I said, "I'm sorry if I'm annoying you guys, but I'm not trying to embarrass you by asking a question. I'm truly interested in what you're doing and trying to clarify it." And they just thought I was, a pain in the ass. So I said, "I'm trying to learn something here, and Jack has got a lot to teach us all. So you should be asking questions too." And they just gave up on me. Some of them didn't concur with that. They thought I was, a nice guy, and I wasn't being mean or anything to people.
John, would you say that your experience at Chicago sealed the deal that you would pursue a career in academia and not go into industry?
Yeah, I would say that, right? Yeah, I think Hans Brinsinger really got me into the field that I pursued ultimately. But Jack was a tough critic, and people were afraid of him at meetings. He is so quick, and he was pretty aggressive in the way he asked questions. And when he wrote letters for people, I didn't really read my letter, but it was enough to open a lot of doors that he would say what he did about me. So when I said I was thinking about interviewing in academics again, or for a faculty position, he was supportive. And that was a pretty whirlwind affair, because again, there was still not a lot of jobs, and especially now in academics. But I applied to about 3 or 4 schools, including Caltech, because they had this. It wasn't a real tenure track position. It was called a Noise Research Fellow, and it was supposed to be a 2 or 3 year appointment, and it was paid from an endowment from that somebody gave to honor Arthur Amos Noyes. And a lot of people at Caltech had started on something called a noise instructor, but this was a new position they called a fellow. I think it was sort of modeled after the Harvard. They have these Harvard fellows. I don't know if you've heard of them.
Sure, yeah.
They start out, they're sort of independent, but they're not really tenure track until they get to be an assistant professor. And many times especially at Harvard in chemistry, they didn't really end up at Harvard. They went somewhere else. It wasn't a lot that they didn't, get accepted as a faculty member at Harvard, a real faculty member, but had to move on because it was known that most people didn't stay at Harvard. So it was an okay position, but this position at Caltech, I interviewed for it on Thursday, and on Monday they called me. Harry Gray called me with an offer, and they explained to me very carefully that now you have to understand this is not a tenure track position. It's not like the noise instructors, many of whom went on to become famous chemists at Caltech. This is different. You're going to have to leave after 3 years. This is just a temporary position. But I really was taken by Caltech so much. I had never met Jack Roberts. I didn't even know who he was. And I didn't know any of the inorganic chemists. I remember asking Jack when I got an interview, I said, so who should I talk to when I go? They're asking me who I might want to see. And he said, oh, you should definitely talk to Harry Gray. He's a delightful fellow. I love the way he said it, because that's what Harry is, dead on. He's a delightful fellow. Anyway, I hadn't met Harry. I hadn't met any of these people. I hadn't met Bob Bergman, who became a lifelong friend. Here I am interviewing with these people. I was talking to Jack Roberts, and he said, I don't know if you were fortunate enough to know Jack before he passed on, but he was a very rough sounding guy, but he was a real teddy bear. Just, well, you made titanoxine, you say. I said, yeah, we did, Jack. And he said, oh, I remember when ferrocene was made. I named ferrocene. I said, wow. All right. Then I looked around his office, and there are this whole series of books, The Life of John D. Roberts, several volumes. And so I thought, man, these guys are important. So anyway, I gave a seminar that was different than anybody had ever given at Caltech in inorganic chemistry, because they didn't have anybody doing synthesis. And they were all physical inorganic chemists. Harry's done some synthesis in later years, but he was a very famous physical chemist. And the physical chemists ran the department. There were very few inorganic chemists, I think 2 or 3 at the time. And all the synthesis was being done in the organic laboratories. So when I interviewed, Harry and Bob Bergman were sitting in the back, and Bob told me that Harry leaned over halfway through my talk and said, this guy can make compounds. And Bob said, yeah, we need that. So they liked me for that reason. Anyway, when I went to Caltech to do my science in Noyes Laboratory, taking over for this guy, I think we talked about George Hammond, who was chairman right as I was arriving, and he left and went up to Santa Cruz. Anyway, I moved into his labs, and he was a physical organic chemist. So I was making compounds, and I had to go down to the stockroom to get some glassware that didn't have anything called a 3-neck round bottom flask, which is like an Erlenmeyer flask for a synthetic chemist. So I had to go over to the stockroom in the organic labs to get my equipment. And everybody, I remember Bob Ireland, who was a senior organic chemist at that time doing synthesis, said, I love you, John. You're a synthetic chemist. You know how to make molecules. He was also from Michigan. He was at Michigan before he moved to Caltech. And he liked me for that reason too. But he was always a good friend and supported the fact that I was a synthetic chemist. But that was my opening. And after a couple of years of building my equipment that I still have around and doing some experiments that were impressive, we actually made a dinitrogen complex of zirconium that was crystalline and got a structure of it by X-ray methods, and did some really cool experiments where we showed that it had a nitrogen between 2 zirconiums, and each zirconium had its own dinitrogen ligand too. And one equivalent of hydrazine was formed if you just added hydrogen chloride to that molecule, clean as a whistle. And everybody thought, well, it's got to be the one in between the zirconiums. And we showed by labeling, specifically labeling that one in between, that it wasn't just that one, it was that one half of the time. And then the other half of the time, it was one of the two so-called terminal dinitrogens that were not between the zirconiums. So that was so much fun, those experiments. They were all coming around. And at that point, Caltech came to me and said, all right, we're going to make you an assistant professor. So then I was off and running, even though they told me that I would only have 2 or 3 years to be at Caltech, and I should already be planning where I was going after that.
John, from those initial impressions, besides the individuals that you interacted with, what did you find special about Caltech generally, beyond the the few people that you talked with before you made this decision to join?
Well, remember, I had 3 days. I had less than 3 days to join. I guess I got back on Saturday or something, but it doesn't matter. I guess I remember walking around campus. I was put up in a room in the Athenaeum, the old Athenaeum, where it was a real, like a YMCA room. It had a bed and a telephone and a desk, and that was it. And you could barely move around in that room. Anyway, they put me up in this room, and I thought, boy, people come here to work. So right away, just from the room at the F, I thought, man, they're serious. And since I didn't know anything about California, I'd never been to California, I'd never been to Pasadena, never been to Caltech, I decided to take a walk that evening. And so I walked around. I walked up the Olive Walk, and I walked around looking at some of the buildings that had lights on in the windows and things. And I saw people working at night. And I just got the feeling this was a place people were driven, and they were, they loved what they were doing. Gee, maybe I'll get a job here. This would be good. So I like that. I like I like the people that I talked to during the interview. And I like the students and postdocs because they were like I was at Chicago. They were asking questions and they were excited and they were obviously very bright. And I was right that Caltech was a place I would never have been accepted to as an undergrad. And I thought, well, I'm really lucky. I don't have to leave like an undergrad would. So I felt like it was a great place for me to start my career. And everybody was just so supportive. Everything I did. So I was right. And my wife, Diane, I told you, she grew up in Tucson. She was born in Colorado, but her father, I said, was in the Air Force. He was based at Davis-Monthan Air Force Base in Tucson, Arizona for like 10 or 15 years, which is unheard of. I mean, they rotate out of a place in the military pretty quickly. But for whatever reason, he was there for a long time, and she went to high school there, and she was in love with the West. I got tired of hearing about the West. It's so great. I got to go see it sometime. But when I had an offer at Caltech, she said, take it.
John, was the situation any different if you had joined as an assistant faculty, tenure track, in terms of setting up the lab, in terms of your interactions with students, teaching responsibilities, besides the term, the soft money basis for this initial position, was your research and teaching life any different than it would have been if you had joined as a regular tenure track faculty?
Yeah, that was pretty confusing to me. I didn't know what I had to do. I knew I didn't have any responsibilities to teach a class. I was just supposed to do my science and not be bothered with the committee assignments and things like that and teaching. But it was funny because they let me talk to first-year graduate students. And my very first student was a fellow from Chile who was spectacular. And he said, he told the people that he wanted to join my group, and they let him. Even though I said, I'm not sure I'm going to be here after 3 years. His name is Juan. And Juan said, I don't care. I like what you're doing. I want to do that. And so he and I was like Hans and I working in the lab all the time. We were working in the lab all the time too. And I was working with him, showing him everything I knew. And he became a better synthetic chemist than I am. He is amazing. But anyway, they let me have a grad student. And I remember I needed a glove box, a commercial glove box, which you have filled with helium or more commonly nitrogen gas to keep air and water away from your compounds. And I went to John Balbestouler, who was the chairman of the division at the time, and I said, I have a need for this glove box. And he said, how much does it cost? And I told him, and he said, okay, buy. And so they bought me equipment, and I had, with my position, I had some, expenses for equipment and things like that, minor equipment and chemicals and things. But a glove box was a big purchase at the time. $15,000 was my annual salary, that kind of thing. So, but he didn't blink. He just said, okay, buy it. So they were acting like I was a regular faculty. You remember when it came to, my research program, what the expectations were. They expected me to do really well, even though they were expecting to get rid of me right away. They wanted me to do well so I could be like a Harvard fellow and go get a good job somewhere else. So I guess I had a break because although, nowadays when we hire a faculty member, a new faculty member, certainly in chemistry, we don't expect them to teach a full teaching load. We give them maybe a half, or even give them a whole year off to get the research operation in place and get it running before they start teaching, especially in a large class. So, although I really liked teaching, I was a teaching fellow at Michigan. I like doing that. But I'll tell you a funny story, just an aside. When I went to Michigan, I had a very strong Southern accent. I didn't go to Chapel Hill, I went to Raleigh, and I was speaking like that. And I can still do it when I go back there. I still have a twinge of one. But when I went to my first teaching session as a teaching assistant in chemistry, the first chemistry class, they have it broken up. And all the engineers take this one class that I was teaching assistant in. So there were like 30 of these people sitting in my first rec session. And I walked in and I said, hi, y'all, I'm going to be your TA. They all looked at each other and some of them started laughing. And I soon realized I'm not going to have any credibility unless I get rid of most of this accent. So I worked very hard in the next couple of months to get rid of my Southern accent. And people after that didn't really believe I was from the Southeast. They asked me where I met my wife, who was from Tucson, and she had a Southern accent from being with me and Raleigh and things like that. So anyway, I like teaching, and I also enjoyed teaching a nursing section of the class. And that's when my son was born, and they all came in knit booties and things like that for my baby boy that was just in the University of Michigan Hospital. They all came and saw Diane. So I guess I had a good rapport with students, and I enjoyed it, but I didn't have that opportunity as a noise fellow. But I did have the chance when I started to go to other people's classes. So I would I remember sitting in on Aaron Kugelman's class, sitting in on Bill Goddard's class, Harry Gray's class, some of the organic classes, just to see how people taught at Caltech. Because, as an outsider, you would think these students, they should know everything. And they're brilliant, and they are brilliant. But I didn't realize as a beginner that they don't know things they haven't been exposed to. So you have to, slow down and teach them, you know, in a sort of normal curriculum way. You can't just sort of say, why don't we go right to the advanced concepts? And so I had some things to learn about teaching at Caltech, but everybody does that comes. They're intimidated by the average intellect. Anyway, I was treated as the noise research fellow, pretty much like a faculty member, except for the teaching and the faculty committee assignments. I didn't do those either. So I just had to do my chemistry.
John, last question. John, last question for today. As you were developing your expertise, relative to your new colleagues, relative to the exciting things that were happening in chemistry at Caltech, what did you see as your niche in terms of the projects to work on and where you slotted in the overall research effort of the faculty at that time?
Well, I've sort of hinted at it already. That we didn't have a synthetic effort in inorganic chemistry at Caltech until I arrived. There were people making things, but they were just following recipes other people created and published. I was devising synthetic methodology and making compounds that had never been made before. And in inorganic chemistry, that was new. And I was also asking questions about mechanism, like I just told you about this dinitrogen compound of zirconium, where we did some labeling studies and tried to rule out certain mechanisms. And so I had a mechanistic ability too. And I started collaborating right away with Bob Bergman on a new area. In fact, we shared graduate students for a while. And he is a very famous physical organic chemist, but he didn't know anything about working with air-sensitive compounds and working with organometallic compounds. And he was taken by it because physical organic chemistry was becoming a mature subject, as they say, which is a bad word. If your field is mature, it means the number of opportunities for new things is small. And Bob was looking for a new area, and he got to become a very accomplished and famous and impactful organometallic chemist. And he started working with me, sharing student, and even his new postdoc, he had come over and worked with these cobalt compounds on my vacuum lines and things like that to learn how to do that. So I was teaching my colleagues how to do this organometallic stuff that some of them ultimately switched to and became famous, like Bob Bergman. So I guess I was teaching my colleagues, and they were teaching me a lot more.
Well, John, that's a great place to pick up for next time.